My name is David Reese, and I work with Wolfram Solutions, which is one of the consulting arms of Wolfram Research. And for the last several months, I've been working internally on making use of our tech stack to extract computable content from textbooks, things like that for educational content. And the particular application that I'm going to talk about here is curating content from OpenStax textbooks. And as a particular application example, you'll see some stuff from related to chemistry education from their textbooks. So what is OpenStax? And this is, by the way, just going to be kind of a sort of a very high level view of an application of our technology. You can, of course, contact me if you want to have further discussion on this and so forth. But so what is OpenStax? OpenStax is an open source initiative out of Rice University. They publish open source textbooks, a wide variety of these. Let's take a look at those. So large numbers of textbooks. Here's their chemistry textbook, organic chemistry, a couple of basic chemistry textbooks. You can go in here. All their textbooks are available for free as a PDF, or you can view them online. I'm not going to submit any money right now. And they're all there for anybody to use. So that's an example of their textbook viewed online. Their PDF versions, their Microsoft Word document versions of them, and there are print versions of them at a fairly modest price, I don't know, maybe $50 per textbook. So that's what we're working with. Their textbooks are all actually built. The HTML, the PDF, and the other versions are actually built out of a custom XML markup that OpenStax has created, which is referred to as CNXML. And the way they refer to it is the lightweight markup language for marking up educational content. Because it's all out there in an XML form, we can use our tech stack to see whether we can extract content from it. Each of their textbooks is sitting out in GitHub, so you can actually download the Git repo if you want to and look through it. Let's look at a finance text, for example, and there's a hierarchy of folders in here which make it very easy. It's a standardized hierarchy which makes it easy to work with. Here is, the chemistry text. I think I may have pulled up a different text a moment ago, but here's an example of their chemistry text, so you have an idea of what it looks like. Some of the things we'll talk about as we move along here. And the chemistry text as it is in GitHub, so I'm actually pointing out to their GitHub, but I've downloaded it to my machine. It's organized into various media files like images and so forth, individual modules. I'll click on this in just a second, and one module for each chapter, and a thing called a collections file. So there's two different textbooks here. And the collections file actually gives you the organization of the various sort of top level sections and their subsections, and which of the media files, which of the module files are in each. Module files look like this. Pick a random one here. And this is a view of the CNXML for this. Happens to be a section of the text called classifying chemical reactions here. And you can see it's very heavily marked up, as XML files typically are. And if I were to scroll here at some point, I might also see some MathML markup in here, if there are equations or things that are formatted as MathML. So you could take any of these CNXML files and take them and, with sufficient prompting, push them into an LLM and ask the LLM to figure things out about it. And I've tried things like that. But it turns out that you can really use the Wolfram tech stack to basically to parse those CNXML files and turn them into something that's much more computable, turn them into a string that I mark up, that is very amenable then to actually doing string manipulations to pull out pieces of content and to reformat in various ways so the LLM understands it well. So how do you do that? Well, we use our overall symbolic XML capabilities, which you can read about here. And some of you may be familiar with all that. And once we've gotten the things in and symbolic XML, then we can do symbolic manipulations on that to turn that into a computable string. So actually, here's just a particular section of the textbook. This is one that I'm going to use just so you have it in your memory as we move along here. And if I bring in, so this is the CNXML source for that particular chapter of the textbook. If I go ahead and import that, let me actually execute this because I've saved it in here in case I want to do some more computation with it. And I simply import that CNXML source, the XML marked up, their XML original marked up string, and you get an XML object. And the XML object is a hierarchy of XML elements, and the XML elements may contain XML elements, and so on down the line. If you go through the OpenStax various textbooks and you scrape out all the possible XML tags that they're using, you find out that it's actually a fairly small set of tags. Pretty, something that's pretty, that you really probably can tackle. Okay, so it's a well-defined small list, except for MathML, but we know how to handle MathML markup inside the Wolfram language. So how do we handle something like the symbolic XML thing that we have up here? Well, what you do is for each particular XML element, you may have, if you understand how it's set up, there may be the string content or some other XML element in here, and you just do a delayed rule and replace that with something where you've marked it up with what you want to mark it up with for future use. In some cases, you may need to go into it, example of MathML, and turn that MathML content into something that you have to write a piece of code to convert that MathML into something else. The little function that I have in here that I've written will take the MathML and convert it into LaTeX. And just so I can pull out the LaTeX things later on, I put them inside a little LaTeX markup, tech markup in here. Okay. And then the end result is something that looks like this. It's a lot cleaner than the XML. And we have all sorts of our own markups, so we can pull out individual bits and pieces as we wish. So example, right, is that particular, this is this string up here, this little iconized thing here. And if I go ahead and execute this and pull out the pieces using a string cases, I find all the tech that was inside of there. And, excuse me, and then given the tech, I can actually turn that into formatted Wolfram language, a Wolfram language cells and so forth. So if I execute that, I can pop up a notebook, and you can see that these are the original LaTeX that have been formatted very nicely. Even more important when we're working with a mathematics textbook. So in sort of a high level summary, what are we doing? We don't need to leave the Wolfram tech stack to accomplish what we need to. Symbolic XML, we can import the original MathML markup. We can perform various round trips through the various formats, whether it's symbolic XML, MathML string, LaTeX, Wolfram language, formatted expressions. In a typical math textbook, there's going to be hundreds of these, so thousands, about 20 or 30,000 of them in a typical math textbook. And it's actually a very good text for the Wolfram language ability to move in and out of LaTeX strings and so forth in MathML. And in fact, in the course of doing the project, we found some bugs, submitted them to our internal bug folks. Our developers fixed many of them. Some of them are still waiting to be fixed. But it was actually a very nice way of coming up with a variety of bugs that we can pass back into the company. I can pass back into the company so they can work on it. Other things that we can use, you'll see that I'll mention having used, is the Wolfram Cloud. So the various media files, we can put them up on the cloud. So if we create an application for somebody, those media files are no longer sitting in the Git repo. They can be on our Wolfram Cloud. And so applications that are using LLM, applications that are using what we're doing here can then reach out to the cloud to pull in those images. You'll see examples of that. We can create semantic search indices and do semantic search on this. We can create LLMTools that, in combination with semantic search, can mine a textbook for bits and pieces of it, depending upon the question. We can use the new Wolfram Alpha step-by-step LLM API to solve problems that Wolfram Alpha might be able to handle and give the full set of steps and hints that can then be passed into the LLM for pedagogical purposes. I think Jason Sonnenberg mentioned some of those capabilities that Wolfram Alpha now has for chemistry, but also for basic mathematics and calculus and so forth. We have a lot in there. We can use Chatboooks, we can use LLM synthesize, we can use the whole Wolfram language LLM related tech stack once we actually have curated that content. So tiny example. So this is an example of a symbolic MathML expression. This is converting that into the MathML string. So we're just importing that as XML back into its original MathML. Given that we have MathML, we can convert it into a box structure. Converting it into a box structure, we can then go ahead and print it out as a cell. Given the box structure, I can turn that into LaTeX. Yeah, so there's LaTeX. And given the LaTeX, I can import the LaTeX again, part of the round trip, and convert it into a formatted output. And almost all the time, this is extremely successful, even for these math textbooks. Occasionally, there's a bug and it doesn't work. And if it doesn't work, you can capture that and you can go ahead and actually say, well, I'm going to pass the MathML string over to an LLM and I am going to give it a prompt. Let's see what this prompt is over here. Just tell it how to handle converting MathML and make sure you get all the escape characters and so forth in the LaTeX that it will create, and ask the LLM, just give it a moment here, it's busy computing. So I just went out to GPT-4o and asked it to convert it into LaTeX. It did that, and then this LaTeX, of course, looks like that before. So that's a little bit of a peek to some of the internals of what we're doing here. There's a lot of backend code, a lot of top-level mathematical functions to do a variety of things with the converted CNXML file. So I've written a little UI that allows us to play with that. So let's just pop this guy up here. Give it a moment. Okay. And so let's go ahead and just sort of load one of those collection files. So here is, I set it up so I'll point directly to this directory as startup, just for ease. Here is a chemistry textbook. Give it a moment to parse that collections file. It's done. Here are the all the chapters. And let me remind myself of the one that I just wanted to take a look into. It is this one, 68,742. So I'm going to find that. 68. There we go. Okay. And so the function that processes this, that replace repeated, if I go ahead and click over here, the function that actually executes that is reading in that CNXML file, doing all the replace repeats on it, converting anything that was MathML into LaTeX, and it gives an answer. It takes a little bit long if it's a math textbook. There's some debugging tools that I have in here. I see that actually, so there was only 35 things in here. You saw that before when I popped up a notebook with the formatted MathML expressions, and it didn't have a problem with any of them, so that's fine. 18,000 tokens in this particular textbook section, and so forth. I can pop open this, and we can take a look at the resulting cleaned up curated thing. There's a little bug in Mathematica. But if I do that, here is one of their, you can see is one of their media files. It happens to be sitting on my disk because I didn't put this one on the cloud. So what are some of the things that we can do with this? One thing that we can do with this is we can open up a chat book. So here's a chat book. I'll explain what's going on here in just a moment. And let me find, so here's a chat book. And what have I done in this particular case? I set it off to go ahead and execute the first chat input cell that I populated automatically. But what's in here? Let me open up this cell. What I did in here is I've put a prompt in here that tells the LLM how to work with the content from that section. And then I said, and use all the stuff that follows. And here, this is the kind of strong-armed thing. I put the entire curated text in here. And something like GPT-4o can handle this just fine because the GPT-4o context limit for the input is like something like 128,000 tokens. But given that, and just find my, if I go ahead and sort of ask this a question, in here, I can pop in a question and see what it does. It's just going to use the content in there, and it's going to go ahead and it's going to do its best. Sometimes the LLM goes ahead and actually tries to create things on its own. So this is not a very good response over here. But further down here, and you can prompt it not to try to do this. I haven't done that here because I'm working with sort of my generic code rather than something very specific for chemistry. But you can also see here, not quite the right size, it also pulled the actual content directly from the Git repo for the media files. So with more sophisticated prompting, in this particular case, targeted specifically to the subject matter at hand, I can have it suppress trying to do this and only to use these, or when it wants to actually create a response for something, to have it actually reach out, for example, to Wolfram Alpha or the Wolfram language to actually create the graphics. So that's an example of that. But you can carry on a full conversation with the entire textbook through here, having sent into the LLM the actual entire textbook section that we're working on in here. But that's a little bit, perhaps too much to send into a textbook. An alternative is to go ahead and to take all of this and use our semantic search functionality that's now in 14.1 and to create a semantic search index. So let me do that. It's creating the semantic search index on this entire text. It's done. And now I'm going to open up a chat book here. Let's see what happens here. So this is a chat book. And if you take a look in here, it actually doesn't have the whole textbook in here. It just has a reference to an LLM tool that I created when I clicked on that button that refers to the semantic search index that it just created. And let's take a chance and put the same question in here. And let's see what happens. So here it is. It went ahead, it's calling the LLM tool, and having called the LLM tool and with appropriate prompting that says, well, use the result that the LLM tool found, go ahead and now answer the question for me. And we can even see what it did. When it did a semantic search in this, it converted this, the LLM converted this into a somewhat simpler question. I've prompted it to do that. And it said, from semantic search, get 5 chunks. And the chunks were 512 tokens long. And so in here, you can see what it got. Here it is. Oops, you have to paste better. Okay, I copied the wrong thing. So this is what it got. Okay, so this is the string join of the 5 chunks that it found. And actually, this illustrates something that's actually interesting about the OpenStax content, and it's worth keeping in mind, which is OpenStax does an exceedingly good job of providing alt text to the content that they provide. And this is actually very, very helpful to an LLM when there's an image involved. Okay, so that's another application here that we can do. Another thing that we can do, since we marked it up, I can click over here and wait a moment. And now I've taken the curated version of things and created a Mathematica notebook version of it that corresponds very closely to the version that was in that OpenStax is publishing. Okay. So what are some other things that we can do? And I just want to talk you through various applications that you can do once you have all this marked up version of a chapter that was originally in CNXML form. So you can process the CNXML form into something that we can then work with. One of the things you can do, and I haven't shown you this here yet, but one of the things that we can do is have the LLMs, it's kind of a meta prompt, right? You take the entire chapter of the text, and you tell the LLM, here's this section, here's this content. I want you to write a prompt that an LLM is going to use when it has access to this content. So it's basically a custom prompt. You write a prompt to the LLM to create a prompt. And the LLM does a very good job of that. And then that can be used in various applications where you are pointing to the original text and you're asking the LLM to do something with it. Well, you've created automatically from the LLM a prompt to do that. So that's an example of this. Another thing that you can do here, and there are various strategies for this, but is the following. Well, it's a chapter of text. I'm a teacher. I'm not going to teach that chapter on Monday. I'm going to take, maybe 5 days to do it, maybe 7 days. So I can hand an LLM the full chapter of the text. I can give it a prompt that says, essentially, this needs to be broken up into mini curricula or lessons that are lesson by lesson sequentially, and ask the LLM to create those curricula. So essentially, they're carving up the original content of the chapter into lesson-sized pieces. And for each of those lesson-sized pieces, you ask the LLM to make a custom prompt for that lesson-sized piece. So again, so then you actually have an application where you can actually work on essentially a lesson-by-lesson basis and put it in a chat book or some other end sources. Some of you may have seen Teo Gray's recent talk, I think it was just before mine, in some other stream, about the AI tutor environment, what he's calling the Jerrybot. And the Jerrybot is a particular application for this AI tutor environment that Teo Gray and Jerry Glynn have written and are writing for that environment. But you can also go ahead and automatically create one of these curriculum notebooks that, when dropped into that AI tutor environment, will work in that AI tutor environment. And part of the process of doing that is to break up each chapter into a set of lessons and do what I just described. You can also, as I've talked, you can create semantic search indices, you can do semantic search, and Stephen wants to coin this new term called computer augmented generation. Retrieval augmented generation is the general concept of pulling things out of a vector database and using them. But and I've described, and you saw an example of an LLM tool that was using semantic search to pull content out of a piece of the textbook and so forth. So this is just a kind of a high level diagram that you can meditate on, but basically describes the various workflows that I've been talking about. And of course, there may be many others, right? But the main point is there's some set of original sources, and for OpenStax, it's their authors, and their authors write things and give them to OpenStax, and OpenStax runs them through some processing of those. They may get Word documents or LaTeX documents, or who knows what they're getting. And then OpenStax takes those things and converts them to initial version of a CNXML file, and then by hand, with a lot of people and a lot of editorial work, mark it up in great detail. So we are working starting from here, and I can put some of the media on the cloud, but then I can get over here, and this is my computable text that we've been talking about, and we can take it in various directions. I showed you a Mathematica notebook popping up. I showed you going through creating semantic search indices and creating a RAG version of things. I showed you breaking things up into lesson level things and turning them into this and so forth. And of course, many of these things could also be sent off to the Wolfram Cloud as an application. Now, OpenStax has all of these textbooks, pre-created for you through all of their hard work. But, and this is what OpenStax is doing, but, what maybe you want to maybe you've got content and you want to write sort of a mini textbook for your class. Can you leverage these technologies that we've been talking about in that? So one thing that I started working on is actually using a Mathematica notebooks as an authoring method for then sending it into this text, this application of the Wolfram tech stack. So this is just sort of a reprise of some of the things I've showed you, but a couple of other things that I didn't show you when I popped up the UI for you are in here. So this is the cleaned string that we got here, but since it has been marked up very nicely, we can actually pull out things like the examples that are in here. Examples in the OpenStax lingo are the exercises that are within the text that are part of the pedagogy of explaining the concepts as they're going along. So they may be all worked out and have a lot of detail in them. And then exercises, which are the problems at the end of the chapter. So you can mine the OpenStax textbooks for all the problems that are in them and pass them into some other workflow. A place that they might go into, for example, is in our Wolfram Language question generator and so forth. OpenStax stuff are subject to Creative Commons license. I put that here. The Git has some README text, but I mentioned to you the idea of asking the LLM to create a prompt to use when injecting the full textbook So here is a prompt that the LLM created for that entire textbook section. So that would govern a user working with that. And then I'll come down to here in a minute. The subcontent is the process that I said to the LLM, well, they're going to be lessons. Break it up into a set of lessons. And so with a sequence of prompts and stages in doing this, the LLM in this case created, I don't know, whatever it is, half a dozen, 8 lessons. And inside of this part of the end result of the computation that the backend mathematical functions are doing are these. I'm going to move over to one of these lessons that has a little more here, like this. So this is just a very high-level summary of the lesson. This is the curriculum that the LLM created for that lesson. It's actually in Markdown form. And here is the prompt that I had the LLM create to use with this curriculum. And in fact, you can go ahead, this might take a little while to run, so I did a saved version of those lessons in here. So here are those lessons, and you can see that within each one, you can see that there's an individual sort of shorter lesson in each. And you can pass these various things on to a chat book using those prompts and so forth. We'll see an example of that in a couple of minutes. The other thing that we can do is, given the fact that we have the full textbook, we can actually, it's on my little notebook thing here, you can have it create a notebook specifically for working through the workflow of actually processing the entire textbook. I think it costs about $150 worth of tokens to process this particular textbook. But once you have it, you don't have to do that anymore. And it will do all sorts of things like put the media files on the cloud. It will process the entire textbook. It will create a semantic search index for the whole textbook. So here I have saved on my computer this semantic search index, which is for the whole textbook. And and I can get rid of this. Then I can ask a question of that semantic search index. This question, blah, blah, blah. And these are separated by lines here. These are, I've asked it to give me 5 items in this. So these are the 5 chunks that it got from the entire textbook from all 80 chapters. Another thing to bring to bear on it is the notion of re-ranking. There's a notion when you're doing semantic search that semantic search gives you a bunch of chunks. They may be pretty good for answering your question, but given the question, maybe you want to sort them into a better order. So the one that's best for answering the question. So they're sorted in the order that is sort of best for answering the question. In that case, you may want to go ahead and do things rather than getting 5 chunks, you may want to get 20 chunks, then re-rank them and then take the top 5 from there. So that's an idea here, which I've only recently implemented in here, but so I don't have a demo of that, but it actually helps a lot in getting your semantic search to give you what you need. And then you can go ahead actually and create applications like this. I'll try to get through this. I created an example of this pre-computed in a chat book just for efficiency because we're getting near the end of our time. But the idea here is that you can pick a random quiz. I said, give me a problem. It found a problem from this section of the textbook. Right? You can pick a section. Okay. It's each section, and these are the high top level sections, and these are the chapters from OpenStax. Okay, I haven't winnowed them down into lessons here. Okay, and you can ask a question, it gives you a question, and then you can say, okay, well, give me the steps to find the first one. And you can then go, well, then automatically as an LLM tool, it goes up to Wolfram Alpha step-by-step API and gets the steps from Wolfram Alpha. And this is then prompted to use those to give the answers, the step-by-step answers to the student. The other thing is you can ask a general question of the entire textbook. So I did there, okay? And it went ahead and did a query into the entire textbook with semantic search and found content from there and started having a conversation with me. So that's that. And the final thing I wanted to show you is the work in progress, which is, well, what if I want to use Mathematica as an authoring environment? Let me start here because I've got a bunch of stuff and I just want to make my own stuff and then be able to use it in all the final versions that we've just talked about. Well, here's a little bit of code with some functions that I've written, and you're not going to look at this in detail, but here is a pretend version of a Mathematica notebook. I happen to have stolen some of this content from the OpenStax Chemistry text, but imagine that I wrote this, yesterday evening. And what this bit of code is going to do, and let's just do this live. So it's now running. I think it's running. Now I have to do Shift Enter. There we go. It's reading in that notebook. It's parsing the individual cells in that notebook. It's figuring out what the type of each one is. And as I finish, okay, and it's done. And then it's giving me a little notebook so I can take you over into the directory that it created. I've time tagged it. And you can see that it's yanked out the media here. These are the various media that were in that notebook. And that it has created a connections file, a collections file. And it has created a CNXML, a marked up CNXML file. So that given this, I can then go ahead and do the various sorts of endpoints. So actually here I can select that collections file, the one I just created, go over here, and then come back to the beginning of this talk where I did this earlier on and run that on that. And so there it is in our new markup. And as an example, let me see whether I can actually take that back into a Mathematica notebook from whence it came, but building it off of this computable string. And if I wait a moment, it will process it, and there we go. And all the other sorts of things that I talked about of making semantic search on this item, I could batch process that and so forth, are all, we've closed the loop in this talk at this point. Just a few screenshots of things that we could do. We could create one AI tutor end notebook and so forth. And so just in summary, it's a good leveraging of the Wolfram tech stack to be able to take this CNXML format, which when I first started working on this, I got worried that I wouldn't be able to really do much with it, but turn it into something that's exceedingly computable and then can take a variety of paths through our tech stack to get to various endpoints, in particular things that we can use for LLM governed usages in things like Chatboooks and LLM synthesize and the rest of the things that we have in our tech stack for interacting with LLMs. Once I've gotten done with all of this, write all your course materials in Mathematica notebooks. You should be all ready. But ultimately, the idea here is that we set up things so that you'd be able to write things in Mathematica notebooks with the various cell styles and so forth, so they're amenable to passing into this technology workflow that I've talked to you about here today. So that's it for what I have to say. And so I'm just actually going to scroll through. Yes, somebody asked me, will I share the presentation notebook? And yes, I'm going to do that. I recommend that you also, refer to the video, just because a number of the things in here, you're not going to be able to see live, but I'm putting screenshots in there so you at least have the details of things. Can OpenStax textbooks contain So I'll just keep answering questions. If people need to go to other things, of course they can leave, but I'm just going to scroll through the questions here so I've covered everything everybody has asked. Somebody asked, can OpenStax textbooks contain interactive elements when viewed in a web browser? Interesting question. OpenStax textbooks contain, the static JPEGs and so forth that appear in the textbooks. They contain links sometimes to external resources that OpenStax has provided. So there sometimes will be links in the textbook that take you to YouTube for particular videos. And so those obviously, if you click on them, they'll take you there. In OpenStax has an introduction to Python. Probably shouldn't be, advertising some other language, but an introduction to Python, which has in it examples that open up in a browser that use the JavaScript, mini version of Python that runs in a browser, and those reside within the OpenStax. The code for that resides within the OpenStax the media directory in their Git for that given textbook, and and those, when clicked on, will in fact open up in a browser and and do exactly what they should for OpenStax if it's in the OpenStax published HTML textbook. So that works. Is my LLM prompt for converting tech available in the prompt repository? No. Oh, hi, Jason. That's Jason Sonnenberg. So it's one of our folks here, and it's I will do that. I've also just this morning, Jason was writing a prompt for using OpenAI to do a poor person's version of re-ranking. Although there are actual re-ranking models, OpenAI doesn't have one, but they are out there, and in a new version coming up of the semantic search paclet, I am told that they are actually going to have a native re-ranking LLM in there, so you can do semantic search and then send it through that. Somebody said, if you heard me correctly, I said the Wolfram language on some rare occasions converts MathML to LaTeX incorrectly, but GPT-4 does it correctly. Is that what I said? Actually, what's happening in that case is that occasionally there is in fact a bug, and there's actually like a failure return. So I catch that failure. And when that happens, then I go ahead and send it off to the LLM, the MathML string, and then it will create a LaTeX string. I've had the developers fix almost all of the bugs that I found on that. I have a list of another half dozen of those which I need to give to them in bulk and ask them to focus some energy on that when they have the cycles. Somebody asked what I and Stephen mean by and actually he meant computation augmented generation and how it's different from RAG. I think Stephen, and he in fact invented the term like 2 days ago. I think what Stephen is really meaning there is that it's not different from RAG, but it is leveraging our tech stack to do more with it than simply sending a piece of content gotten from a semantic search on a vector database, but actually getting that and also making use of our tech stack to do a wide variety of things like the Wolfram Language Evaluator, writing Wolfram language code based upon that, and so forth. I think that's what he means. Somebody said, I would hazard that it could not be based on my use of LLMs to write Wolfram language code. I'm not 100% sure. That's Jim Larkin. I'm not 100% sure what you meant by that. So I'm not quite sure, but you can use LLMs to write Wolfram language code. Anyway, I'm not quite sure what you mean. So if you wanted to grab my email address, some DREISS@wolfram.com, and if you wanted to send me a longer version of your question, I'd be happy to answer. Bob Knockbar is asking me if authoring a notebook file, how are input and output cells handled? Bob is a friend of mine, and he works in Wolfram Solutions. And so the short answer, Bob, is I'm working on it, and there will be custom code for doing that. But actually, at the moment, if the output cell is a formatted Mathematica expression, what I'm doing in the very early days, Bob, it reads that in, and it converts the box form of that into LaTeX, and it puts it inside of the CNXML. And David G, just to be clear, can JavaScript run in an OpenStax textbook that is being viewed in a browser? That's an OpenStax technology question, and I'm not sure. I think what they do, for example, in the case of the Python text where I mentioned they have little applets that run in a browser under JavaScript, I think what they do in their HTML version of that is when they read in that piece of the CNXML code, it has been marked up so that in HTML, it's actually placed inside of an HTML, I forget what the terminology is, or sort of an embedded HTML piece that appears inside the web. And so one could, could clearly do that. I don't know that one can do that in a notebook at this point. That's a good question. So So they are doing that. And if you're scrolling through the Python textbook from theirs and you get to one of those, I believe it'll be working within, an enclosed environment inside the window of that cell. So it's correctly interleaved in with the pedagogy. So I think that may be all of the questions that I had. But really, anybody, grab my email address, send me questions, and I'm happy to answer them and engage with you in any other discussion on this. So if anybody's still here, thanks for attending, and have a great weekend.